Hi all, these are the notes for 5.2, which is more properties of exponents. This is a really short section. It's going to be your favorite. So there are two additional rules for exponents that we need to do first. The first is the power rule, and then there are some properties. So the power rule works like this. If I have something being multiplied, so let's say 2 times 3, and they're both being raised to a power, let's call it 4. What I can do is distribute that exponent, but only if it's across a multiplication, or as you'll see in the second part, a division. This is the power rule. So what I can change this into is 2 to the 4th times 3 to the 4th, okay? The same would be true as if I had 2 over 3, all to the power of 4. I can rewrite that as 2 to the 4th on top and 3 to the 4th on the bottom. I can go either direction with this rule, which is really handy. I can condense, so I can go divide it up or put it back together, same with the multiplication. But this is essentially what the rule says. So, oh God, that wasn't the power rule. Holy moly, this is not the power rule. This is just a property of multiplication and of division. The power rule essentially says when I have a power to a power, I multiply the exponents. So think of it this way. If I have 2 to the 3rd to the 4th, what that really says is I have 2 to the 3rd 4 times, okay? I have 4 groups of 2 to the 3rd. And so if I count those up, 3, 6, 9, 12, it's really the same as 2 to the 3 times 4, which is 2 to the 12th. That's what the power rule says. Okay, so now let's use that to do some things. Let's simplify what we have here. Well, in A, I have s to the 4th squared. That means I have s to the 4th times s to the 4th, and that is really just s to the 8th. I could just do 4 times 2 is 8. For B, it's the same thing. So I'm really just going to make it 3 to the 8th. 3 to the 4 times 2, 3 to the 8th. You have a calculator, so you should calculate that out. 3 to the 8th is 6,561. Okay? It's not going to be simplified in this form. And then on the bottom, we're going to use both of those rules together because I am going to, well, you can do this one of two ways. Let's do both ways. The first way is to think about order of operations. I'm going to do parentheses first. So I'm going to have x to the 2nd, x to the 5th, and I make that x to the 7th to the power of 4. And then 7 times 4 is 28. So that makes x to the 28th. The other way I could do it is to think about distributing that 4th across first. So x to the 4 times 2 is 8, times x to the 5 times 4 is 20. And then I would just add those together. So I would still get x to the 28th. Either of these is fine. It's just a matter of how you think about it. The first way is more, appropriate for order of operations, but both ways work out, as you can see. All right, so we saw this rule a minute ago, power of a product, power of a quotient. We saw this at the start. Assume A and B are real positive or real numbers. M represents a positive integer. This is how it works. We saw it was 2 times 3 to the 4th. Got me 2 to the 4th times 3 to the 4th. I'm not going to repeat the whole thing. But now we're going to use that. So if I want to simplify these expressions, what I need to do is give the 4 to everybody. So I'm going to have negative 2 to the 4th, x to the 4th, y to the 4th, z to the 4th. And that is going to give me, well, negative 2 to the 4th is 16, right? And then I have x to the 4th, y to the 4th, z to the 4th. I'm not going to combine anything else because none of my variables are the same at that point. I have x's and y's and z's. It's like apples, oranges, and bananas. I'm going to do the same thing in B. You try it. I'm going to give that 3 to everybody. So I have 5 to the 3rd, x squared to the 3rd, and y to the 7th to the 3rd. All right. And so that's going to get me 5 to the third is 125. X squared to the third, power to a power is multiply, so that's x to the sixth. And then power to a power is multiply, 7 times 3 is 21. That's it. For C, I'm just going to give that 3 to both the 2 and the 5. I'm going to distribute it across the fraction. So on the top, I'm going to have 2 cubed. On the bottom, I'm going to have 5 cubed. And that is going to be 8 over 125. If it's appropriate to simplify further there, you should, but there's no common factor for the two of them. And then for D, I'm going to do the same thing, except the 2 in the bottom, when I distribute it to the denominator, so 1 squared to the top, goes to everybody just like we did before. So x squared, y to the fourth squared, okay? So when I rewrite, I get 1 on top, because 1 times 1 times 1 is still 1, 9, x squared, and then y to the fourth squared is y to the eighth, okay? That's how these work. You try the next set. These are a little more complex, but they work the same essential way, okay? I'm going to take them one step at a time. You should pause, though, and try them before I do this. So I have x to the second to the sixth makes x to the 12th. And then I have x to the third. And then I have x to the 14th on the bottom. Now they're all x's I can combine. So on the top, I have x to the 15th. On the bottom, I have x to the 14th because 12 and 3 is 15. And then when they're powers to a power, like exponents in the top and the bottom of the same variable, I subtract. 15 minus 14 is just x. So that whole thing just simplifies to x. You try the next one. So I get a k to the 10th, k to the 8th, and then at the bottom, I'm going to have k to the 8th. Now for me, I'm actually going to look carefully and use my critical thinking skills here. I have a k to the 8th in the top and in the bottom. They're just going to cancel. And I'm going to be left with k to the 10th. You could have made it k to the 18th and then subtracted 8, but for me, I'm going to do the least amount of work possible. Okay, so for this one, before you do anything, remember order of operations says exponents first. So this 3 has to get distributed here first. And then we can multiply. So I have 3cd squared. And then I'm going to have 2 to the third is 8. C to the third is just 3. And d to the third is d to the 9th. Now I can match what goes together. So I have 3 times 8 is 24. C times c to the third is 4 of them, c to the fourth. And d squared and d to the 9th is d to the 11th. Okay, do the next thing, same thing for the last one. When you finish this one, and you should just try it on your own, you should get 64, x to the 16th, y to the 17th. If you're stuck, come into the discussion, ask for help. All right, this is the last step. This is like the most simplification. The first thing I'm gonna do is give the squared to everybody, okay? So x to the 7th squared is x to the 14th. Y squared, z to the 4th squared is z to the 8th. On the bottom, I'm going to have 8 squared is 64. X squared, and then z to the 3rd squared is z to the 6th. And now I'm going to simplify. So I'm going to look first. There's nothing to simplify 64 with. So I'm going to leave it alone. I have x's on top and x's on the bottom. 14 minus 2 is 12. So I have 12 x's left. I have nobody to simplify the y's with. I just leave that y squared alone. And then I have 8 z's and 6 z's. So that means there's 8 minus 6 is 2 z's left. So it's x to the 12th, y squared, z squared over 64. You try the same thing for the last one. When you're finished, you should have w to the 4th, y squared on top on the numerator, over 36. If you get stuck, you know what to do. We'll see you in the discussion.